Assistant Professor in IT Department, Walchand Institute of Technology, Solapur. Today here we are discussing the 8086 pin diagram. Now here, what will be the student can be able after this session? Here the student will be able or they can be know the details of pins of 8086, and student will be able to explain all these pins of 8086 diagram. Here, this is a structure of 8086 pin. Here, the 8086 pin diagram can be work in two mode. That two modes are minimum mode and maximum mode. Here, the pin number 33, which can be shows the minimum and maximum mode. When it is enabled, that is a 1 set to 1, it will be work on minimum mode, and it will be connect with VCC, and they can be work as a minimum mode. And when it will be 0 set to 0, then it will be work on MX, that is a maximum mode. In that case, these all pins are will be get used, and when this will be 0, then it will be work with this GND, and we can be able to connect this GND to another co-processor. Now here we discuss these pins one by one. Address and data bus. Now here in 8086 pin diagram, the pin number 2 to 16 and 39 are time multiplex buses uses to access memory or input and output. They are multidirectional, that is used for input and output operations. Here 80 to 87 carries a low order byte data, while 88 to 8015 carries the higher order byte of data. During the first clock cycle, that is T1, these buses carry 16-bit address, and during the remaining cycles, that is T2, T3, and TW and T4, it carries a 16-bit data. The address data operation is enabled by the ALE pin. The ALE pin, that is address latch enable pin number 25. Here we can consider when ALE is high, that is 1, the bus contain an address of memory or input output, hence function as an address bus, that is A0 to A15. And when ALE is low 0, the bus carries data to or from memory or input output, that is D0 to D15. Means here they are working in a both as a both part. First one as address and second one is a data. When AL is a disable, then it will be work as data bus, and when AL is enable, that will be work as a address bus. Then next, the address, the status lines are in pin 35 to 38. They are time multiplex, they are unidirectional, and during the first clock cycle T1, they carry the higher order 4-bit address of the 20-bit address, that is A19 to A16. During the other cycles, they carry the status bits, that is S6 to S3. The multiplex status, that is S3 to S6, indicate the type of operation to be performed in that cycle. S6 is always set to 0, that is low. S5 gives the current setting of the interrupt flag, and S3 and S4 indicate the segment register being used as shown in the table. When both are 0, then it is an extra segment. When only S3 is 1, then it is a stack segment. When only S4 is 1, then it is a code segment. And when both are 1, set to 1, then it will be a data segment. Now BHE bar or S7. Now BHE is a multiplex with S7. BHE is bus high enable, indicate whether the transfer of a byte is to be done on higher order bus, that is AD15 to AD8. The signal is low during the first clock cycle for read, write and interrupt acknowledgement cycle. During the other clock cycle, it is active, indicating that transfer is to be made on lower order byte. The S7 status information is always held at logic 1 throughout. BHE work as shown below. When BHE and A0 both are 0, then it is it indicate whole word. When BH is 0 with respect to A1, A0 is 1, then it is a upper byte from to add address. When it is a 1 0, then it is a upper byte from or to even address. When both are 1, means there is a none. Then Mn and Mx, there is a pin number 33 which indicate minimum or maximum mode. At pin number 33, the input pin indicate whether the processor is to operate at minimum or maximum mode. The minimum mode, there is one microprocessor, is selected by applying logic 1 to the Mn oblique Mx input pin. The maximum mode, there is a multiprocessor, is selected by applying logic 0 to the Mn oblique Mx input pin. At pin number 32, RD indicate that the processor is performing memory or IO read cycle depending on the state of the S2 pin. It is low whether the 8086 is reading data from memory or IO. This signal floats to three states of in hold acknowledgement RQ oblique GT0 and RQ oblique GT1 at pin number 31 and 30. These are the request grant signal used by the other processor requesting the processor to release the system bus for use. When the signal is received by processor, then it sends acknowledgement. Important to note is that RQ oblique GT0 has higher priority than RQ oblique GT1. In minimum mode, the hold indicate to the processor that external device are requesting to access the address data buses. HLDA signal acknowledgement, the hold signal, that is hold acknowledgement. Then lock. At pin number 29, the signal indicate that an instruction with a lock prefix is being executed and the bus is not to be used by other processor. When this signal is active, indicate to the other processor not to ask the CPU to leave the system bus. In minimum mode, the write bar, that is write output, is low whether the 8086 is writing data into memory or IO devices depending on the status of memory or input output signal. Then at pins 26, 27 and 28 are the status signal that provide status of operation which is used by the bus controller 8288 to generate memory and IO control signal. They indicate the type of transfer to take place during the current cycle. The truth table is here when all are 0, all the inputs or all the status S0, S1 and S2 are 0, then it is an interrupt acknowledgement. If only S0 is 1, then it is IO read. If only S1 is a 1, then it is IO write. If S1 and S0 are 1, then it is a halt. If S2 and S0, only S2 is a 1, then it is a opcode fetch. When S2 and S0 are 1, then it is a memory read. When S2 and S1 is 1, then it is a memory. And when all are set to 0, then it is a passive. In minimum mode, pins 28 operate the memory oblique input and output, which is the signal is used to distinguish between memory and IO operation. When it is low, it indicate IO data transfer, and when it is high, indicate the memory data transfer. In minimum mode, pin 27 operate the data read, transmit or receive, which is used to control data flow direction. High on this pin indicate that the 8086 is transmitting data and low indicate that it's receiving the data. Here in minimum mode, pin 26 operate the DN, that is data enable, which is used to enable transceiver 8286. The transceiver is a device used to separate data from the address or data bus. This signal inform the transceiver that the processor is ready to send or receive data. QS0 and QS1 at pin number 25 and 24, these two output signals reflect the status of the instruction queue. This status indicate the activity in the queue during the previous clock cycle. The QS0 and QS1 table indicating the various status like no operation when both are 0, when only QS is 1, that is the first byte of operation from the queue. When only QS0 is 1, then it is a empty the queue, and when both are 1, then it is a subsequent byte from the queue. In minimum mode, pin 25 ALE address latch enable indicate the availability of a valid address on the address or data lines. Pin 24 is interrupt acknowledgement, that is INTA. When the microprocessor receive this signal, it is acknowledge the interrupt. In pin 23, there is a test, the execution of a wait instruction cause the 8086 to check the logic level at the test input. If the logic 1 is found, the microprocessor suspend operation and goes into the ideal state. As test switches to 0 execution, resume with the next instruction in the program. This feature can use to synchronize the operation of the 8086 to an event in external hardware ready at pin number 22. If the signal is low, the 8086 enter into wait state. This signal is used to synchronize slower peripherals with the microprocessor. When it is high, indicate that the device is ready to transfer the data, hence it is active high signal. At pin 21, the reset is used to restart the execution. It causes the microprocessor to immediate terminate its represent. It clears PSW, DS, SS, ES and the instruction queue. It then set CS to FFF hex. This signal must be high at least 4 clock cycle. When reset is removed, 8086 fetches its next instruction from physical memory. Then clock signal CLK, it uses pin number 19, providing the basic timing square wave signal of 33 duty cycle, that is high or 1/3 and low for 2/3 from an external cycle control. Then power supply VCC and JND. 8086 uses 5 volt DC, that is plus or minus 10 volt margin supply at VCC pin 14. Ground is connected to pins 1 and 20. INTR, that is use pin number 18, that is a interrupt request. It is level trigger maskable interrupt request signal. Then NMI, that is nothing but a non-maskable interrupt. It is a positive edge trigger input which causes an interrupt request to the microprocessor. Thank you.